Hey math kids, in this video we're going to look at section 3.EB and we are going to learn how to make polynomials, make a quadratic function using complex roots. So actually, if we know that this is the root to a quadratic function, we know that its conjugate is also a root. Because for quadratic functions, roots show up in conjugate pairs. As we saw in the previous video, we always had a plus or minus, but this part and this part were the same. So conjugate in this case is just going to be if the imaginary parts have different signs. Notice that the real number 3 has the same sign, but the imaginary number has a different sign. So we use conjugates. Now, we're going to use the idea that x minus r1 times x minus r2 is how we start to plug things in. So what we're going to do is we're just going to change all the signs. So we're going to say x minus 3 minus 5i, and then x minus 3 plus 5i. Once again, I changed all the signs on this purple one, put it right here, changed all the signs on the yellow one, and put it right here. Okay, now we just do a bunch of multiplication. So I'm going to multiply x by all three of those. So x times x is x squared. X times negative 3, negative 3x. X times 5i is 5ix. Now in yellow, I'm going to multiply everything by negative 3. So all three pieces. So negative 3 times x, negative 3x. Negative 3 times negative 3, positive 9. Negative 3 times 5i is negative 15i. Then I'm going to use blue to multiply everything by negative 5i. Negative 5i x. Negative 5i times this would be positive 15i. And then negative 5i, positive 5i is negative 25i squared. Alright. Now, we want to, if you do this correctly, a bunch of stuff should cancel. So, for example, we have a negative 15i and a positive 15i. We have a 5ix and a negative 5ix. We can combine this and this into a negative 6x. So I used those up. And then I'm just going to write the rest of what we have, and then we'll talk about how to deal with it. So we still have an x squared, we still have a plus 9, we still have a minus 25i squared. Alright, so what we want to do on this is remember our shortcut when we were multiplying complex numbers. You can cross out I squared and change the sign, because I squared is equal to negative 1, so negative 1 times negative 25 would just be positive 25. Now these are just constants, and so we have x squared minus 6x still, and then if we add these two together we get 34. And then we can just set this equal to y, and that can be our quadratic function. Okay? Now let's try one more. 1 plus 3i. So if we know that this is the root to a quadratic function, we know that 1 minus 3i is also a root. So what we're going to do is we're going to say x and then change the sign. So minus 1 minus 3i. X minus 1 plus 3i. Once again, change both signs when you're plugging it into that formula. Alright, we will multiply everything by x. X times x, x squared. X times negative 1 is negative x. X times 3i is 3ix. Now we're going to multiply negative 1 by everything, so that's just going to change all the signs. So negative x, positive 1, negative 3i. Now we're going to multiply everything by negative 3i, so we're going to go like that. So negative 3ix, positive 3i, And then this times this would be negative 9i squared. Okay, so we have 3ix, negative 3ix, so those cancel. We have negative 3i, positive 3i, so those cancel. And we have negative x, which would be negative 2x. Now we do our shortcut, cross this out, change the sign. So 9 plus 1 is going to be 10. And then we can just bring our x squared down right here. And since everything's a different color, let's make our y a different color as well. There we go. That's our pretty equation. It's a quadratic equation that has these complex roots. If you need additional help, please come to Math Lab. Until then, calculator.